was in Germany at FIBA a couple of weeks ago, and there was a panel, a guy called Oliver Patrick, who worked in Harley Street for a long time and studied a lot of, similar to what you're saying, how to kind of get people to optimize their quality of life as they got older. And he was talking about some of the kind of key tests that they found were successful for longevity. And you touched on them in your book. And I just wanted more of an update, really. When you're testing for longevity, what are some of the most reliable assessments that you can do specifically for living longer and better?
I'll build my way up.
Okay.
There's a lot of correlation testing done using regression analysis. I don't know if you remember your calculus classes and whatnot, but we've got enough databases now. And the problem is, just briefly, the data is the key, right? Regression's easy, but the old expression garbage in and garbage out, right? GIGO. If we had really solid data, we could draw some really good correlations between all kinds of markers that we use as part of standard testing. You know, CBC, a complete blood count, a comprehensive metabolic panel, assays of the blood or using blood that we say, oh, look, people that have, for example, higher HDL tend to live longer without this disease process, typically of the heart, okay, or the cardiovascular system in general. That's useful, and we're working on. I'm personally actually working on that. Trying to come up with an application algorithm that helps develop that theory. There's some scientists that have already made some great headway there. The second, or the next up from that, I would say, we've got some pretty good correlation with just a simple analysis of your telomere length. That one might not end up being as fruitful as we expected. The one key there is differentiating between longer telomeres because you're healthier. You want me to explain what a telomere is?
Yeah, let's do it.
Okay,
yeah,
so telomere is, the classic example is they call it an aglet, the end of a shoelace. You know, that little plastic thing that keeps it from fraying. Every time the cell replicates, that aglet gets a little smaller, and a little smaller. And when it gets too small, the cell can't replicate anymore. So you want more replications because as the cell senesces, you want a nice fresh replacement to come on through there. So you don't want to burn through that end cap, as it were, of the shoelace for as long as possible. The problem with that is that cancer also has longer telomeres. So it may end up being a good assessment when we can tease out the difference between longer telomeres from cancer versus longer telomeres from good health. But there's a little bit of a wrench in the works because of that. But there is a lot of correlation in otherwise healthy people that don't have cancer with longer telomere lengths, because that's an ability that helps us live longer and healthier than those with shorter ones.
Can you lengthen your telomere lengths, or are they just
through some of these processes of all the things that we talk about, and some of the things I mentioned in the book, ways of, for example, my favorite is exercise. I think it's a great equalizer. Getting enough sleep, things that are regenerative in nature if done properly. We've shown that, there's telomerase that can help with telomere lengthening, and so we even got some supplements. I think probably the most famous is TH65, which is purported to increase your telomerase and therefore help lengthen and certainly slow down the process of telomere shortening. So again, it goes back to that whole thing about biological markers. This is just one that we think has some pretty good science behind it so far, but we'll see. By far, maybe that's a little too dramatic, but by far, the better or the best of them all is DNA methylation. So when you've got the genes, right, and you've got an epigenome, we call and I always botch this because I try and make it something that I can explain the vernacular, but sometimes there's some crossover in the science and it gets confusing. So that's where my editors came in handy too. But there's certain areas of the epigenome, for example, that can be methylated or not. Okay, it's not necessarily a bad thing for a gene to be methylated. It's just which ones do you want to be methylated and which one's not? But by looking at the DNA methylation of various humans' genes, right, we can correlate that with certain disease states or not, certain functions that are being performed properly in the body the way we want them to or not. And with that, we can come up with a pretty good idea of biological age. I think using DNA methylation, if I'm up to date recently, I think we can come up with, like I could take your cells without knowing your age and come up to within like a year and a half of your chronological age based upon, again, different algorithms that are useful for this. But again, we can use that same information and say, wait a minute, this guy's 54, but according to this, we would guess he's 74. Oops, got to do some changing here, okay? And you can, again, as evidenced by the change in the DNA, the methylation or not of the DNA, you can find out, oh yeah, this is working for you or not, whatever it is you want to adopt.
One of the things I was reading was VO2 max and muscle mass. Where does that play a part?
Big part. Yeah, see, these are simple things that, I mean,
yeah,
we can get into the semantics that I either screwed up recently right now with that or not. And the points are harder to get across, but this is so simple. VO2 max, the ability of your body to uptake and utilize oxygen is easily measured and actually pretty easily estimated. But the gold standard is to actually measure it. So, you've seen the classic example of a guy's on a bicycle or treadmill. He's got the mask on, right? He's breathing through the tubes. Well, they're measuring oxygen in and oxygen out. Sometimes the CO2 out and in as well, but typically out. But the VO2 max will tell you your ability to use oxygen. And one of the, so you've got how much oxygen you can utilize on the numerator, and then the denominator includes your weight. So, and I say this because, backing up and keeping it simple, huge correlation, and without a U curve or a J curve where too little's too little and too much is too much, the better your VO2 max, the better we believe your life is going to be in terms of longevity and health. That's huge, okay? And that's with the latest studies.
And that's a very simple thing, isn't it? Well, compared to some of the previous things you were mentioning that sound quite complicated and sophisticated.
Right. And the beauty of that, the reason I wanted to harp on that and the denominator is because, you can go out there and run and swim and do whatever you want to improve that capacity from, the ability to ventilate, we say, and absorb oxygen through the lungs and then carry it with the blood and then get it into the cell and then make use of it in the mitochondria. That's one way that's more complicated and worth developing, I don't hesitate to add. But losing weight, okay, this is one of my theories. I don't think I even mentioned in the book, but if you look at many of the centenarians, I would say most, they're not big people. I remember my good friend Scott Schaefer was in the gym and he was picking up, he's 315 pounds at the time. He's picking up some huge weights. And Lou Ferrigno, who's obviously been around the block in terms of muscle mass, is now down to a much more svelte, really good looking, healthy looking weight. Still, Lou, he's still a relatively good guy. He's good. Scott, what are you doing? He says, I'm looking for the 200s or whatever it was, He says, why? What? He says, well, I'm trying to get bigger. He says, Scott, how many big old people do you know? And that's true. How many centenarians are big? I think it's a major thing to consider because it does come into play. Now, what may sound contradictory to that is muscle mass is also associated with better longevity, and that makes sense. But there's going to be, that's going to be part of that J or S curve, if for no other reason that what I just said, how it affects your VO2 max, right?
Do you know how, when I had this chat with Dr. Gabrielle Lyon about this, like, is there an idea about how much muscle mass is good? Like how big? How much is it?
The simple answer is yes, there's an idea, but there's no one place that we know of. Like BMI would actually come into play usefully for once, in an assessment like that, because that's just basically height and weight, right? So, because again, just using your weight would make sense, and that's what the VO2 max uses as a denominator. For your size weight, and that comes into all kinds of things that you just would think of intuitively like, okay, you only have, 2 kidneys, 1 stomach, 1 liver, and all that sort of thing, and they can be different in size compared to your body, but it's not necessarily a one-to-one relationship. So, if you're too big, how much are you taxing your kidneys? How much are you taxing your GI system? Which I see all the time with patients that are, trying to be big. And well, come on. I mean, I'll be the first to admit, I'm 230. What should I probably weigh? 185. To fit what my choice of parents, requires. But so you think of it, I think of it anyway, in terms of what's functionally good for you and metabolically good for you. Because remember, muscle is a metabolic liability, and insulin sensitivity or metabolic function is an important part of longevity and again, healthy longevity. And part of that goes into the third factor that I think I mentioned there in the book too, is muscle strength. They use grip strength, but they've also used, I think, leg extension strength and others to show that there's also correlation there too. And that goes back to, it's not just about holding muscle only or per se, but functional muscle. You want to be pound for pound, in the best shape. And this kind of goes back to a circular thing. One of the best ways of estimating VO2 max is using your power to weight ratio. So the concepts do interlink if you think about it. And it really comes down to, hey, don't get too big, be strong, and be lean. Right? I mean, if I had to generalize.